Let's look at how to find trigonometric ratios and rules. Please don't forget to like and share this video. We are going to use our Cartesian plane to determine our trig ratios. So this is our Cartesian plane. We have the y-axis, we have the x-axis. Now, at the side of the quadrants where we can find both x and y-axis to be positive will be our first quadrant. And for trigonometry, we read the quadrants from the anti-clockwise direction. That is from the right to the left direction. So this is the anti-clockwise direction. So if this is our first quadrant, we are going to get our second quadrant at this side, as well as our third quadrant and our fourth quadrant over here. We are using this quadrant to determine the basic 6 trigonometric ratios. Over here, let's locate a point at the second quadrant. So we have a point being located at the second quadrant, and the point is P, and the point is having the coordinate xy. So if you have this point located as point P, we are going to draw a straight line to the midpoint of this xy axis. Now this straight line here, we are going to complete to form a complete triangle. So over here, we know the vertical line here is our y, and the horizontal line here will be our x. This will be our r. And we have a picture of a right angle triangle. So over here, we have the 90 degrees angle located here, and we are using the x-axis as our unknown angle, theta. Now we are going to use this triangle to generate the first 3 trigonometric ratios. So over here, we are going to talk about short formulas that will help us to get the trig ratios. So let's embrace ourselves on these terms. We have so, we have ka, and we have twa. So we normally call it so ka twa. So the first name refers to the name of the trigonometric ratio. So the first name is what we call sine, and the second name is what we call cosine, and the third name is what we call tangent. All right, all of them are supported by the angle unknown, that is the angle theta, angle theta, angle theta. We are going to look at their last 2 names. That will be the generation of the ratios. So over here, I have my sine theta equal to, now over here, I have O and H. So the first letter is our numerator, and the second letter will be our denominator. Don't forget we are talking about ratios. So the ratios are also expressed in the form of a fraction. So O over H. Now O over H. And the O is called opposite, and H is called the hypotenuse. And the hypotenuse is represented by R in our diagram. Now over here, when we take sine theta at this place, and the opposite is what we have here as our y, and the hypotenuse is what we have here as our r. So we are going to use y as the opposite here, and the hypotenuse is our r. This is the first ratio. Let's come to the second one. That is the cosine. So we will use cos. The short form of sine is sine, and the short form of cosine is cos. So cos theta. And the cos theta has the ratio A over H. So A over H. And A is the adjacent. So the adjacent is the x-axis. So the adjacent over here is x. So x. And the hypotenuse is the r. So we have r at this place. And that is our ratio. So we have the next one, which is the tangent. And the tangent is shortened to be called tan theta. According to this, we have the ratio to be O over A, and O over A means opposite over adjacent. So opposite is y, and the adjacent is x. So we have y over x. This is the first 3 basic trigonometric ratios. We are going to look at the other 3 that will be made up to be 6, and the other 3 are the reciprocals of the first 3. So the fourth one I'm going to talk about will be the reciprocal of the sine, and we call it cosecant. So we have it here. theta. And cosecant is also shortened as cosec theta. And cosec theta is the inverse or the reciprocal of the sine theta. So cosec theta means 1 over sine theta. So if we have sine theta to be y over r, then the reciprocal will be the upside down r over y. So this is the fourth ratio. That is the reciprocal of the sine. Then we have the fifth ratio. That will be the reciprocal of the cos. So cosine. So you are going to get secant theta. And the secant theta is also shortened as sec theta. So sec theta is the reciprocal of the cos, and that will give you the 1 over cos theta. So if cos is x over y, then the reciprocal will be r over x. The sixth ratio will be the reciprocal of the tangent, which is called cotangent. And it is also shortened as cot theta. And the cot theta, we have the tan theta to be y over x. So the reciprocal will be x over y. So these are the 6 basic trigonometric ratios we can have so far. Number 1 here, number 2, number 3. And the other 3 that follows are the reciprocals of the first 3 basic ratios that we have here. So this is how we can derive to get our 6 basic trigonometric ratios. And I'm going to use it to solve problems in our later videos. Now let's look at the signs of these trigonometric ratios. We are also going to use the Cartesian plane. So for the Cartesian plane, we have our y and our x here. We are going to determine on which quadrant would one of these ratios, either sine or cos or tan, will be positive. Now, since we have this side to be positive, this side to be positive, this side is negative, this side is negative, which means the first quadrant, all the 3 ratios or all the 6 ratios are going to be positive, because the x is positive, the y2 is positive. So we are going to say that all the 3 are going to be positive. All the 3 ratios are going to be positive. Now we have the second quadrant. We move to the second quadrant. When you come to the second quadrant, imagine a triangle is formed here. So our r is always positive. Wherever quadrant we are going to find ourselves, our r is positive. So our x and the y will determine the positive form of the ratio that we are going to talk about. So first, let's talk about sine in the second quadrant. So in the second quadrant, sine has a ratio y over r. And r is always positive. So y here is positive and r2 will be positive, which means at the second quadrant, whatever that we have for the sine is going to be positive. Let's come to the cos theta. The cos at the second quadrant is having x over r, and x here is negative and r is positive. Since one of the number in the fraction is negative, we are also going to have the entire answer to be negative, which we are trying to avoid. We don't need negative ratio. So as the tan also having x in the ratio, which also going to be negative. So we only consider sine to be at the second quadrant, which is positive. So over here, sine will be positive. Sine will be positive at the second quadrant. When you come to the third quadrant, we have sine here, sine at this place, which is y over r, and r is positive, but y will be negative. So sine is negative at this side, which we are trying to avoid. Then when you come to cos, we have x over r, and r is positive, x is negative, which we are trying to avoid because we don't want negative fraction. Then we have tan, y over x. So over here we have y, which is negative, over x, which is negative. There's no r in it, so which means we are going to have the fraction, the numerator is negative, the denominator is negative. So the negatives are going to cancel, and we are going to obtain a positive fraction or ratio, which means tan will be considered at the third quadrant. So tan theta is going to be positive, only tan will be positive at the third quadrant. Let's come to the fourth quadrant. And the fourth quadrant, when we test from the sine, sine has y over r. So y over r. R is positive and Y is negative. So the fraction will be negative. We are trying to avoid negative fraction. When it comes to cos, so cos is having X over R. X over R. R is positive and X is also positive, which means at the fourth quadrant, cos theta is going to get positive ratio. So this will give you a complete science of these trigonometric ratios concerning what we have in our Cartesian plane. So in this form, for you to remember this so fast without stress, we have this to be shortened as cast, C-A-S-T. So we have here to be cast, and this will help you to remember the signs of each ratio we have in the Cartesian plane. So A stands for all the three basic ratios are positive. Then S over here at the second quadrant stands for only sign is positive at the second quadrant. Then at the third quadrant, only tan is positive, and at the fourth quadrant, only cosine is positive. So we will use this concept to answer various questions under these ratios. Thank you very much for watching this video. In my next video, I'm going to look at the application aspects of these trig ratios. Please don't forget to like and share the video. Please visit my YouTube channel and also subscribe to the channel.